Hi, welcome to our presentation, No Drill Press Required, Simulation and Gamification of Precision Machining Labs using Augmented and Virtual Reality.
Greetings. We're excited to share with you today our cross-discipline collaboration with workforce and credit faculty, creating new augmented and virtual reality experiences in precision machining. I am Dr. Doreen Fisher-Bammer, Associate Provost of Virtual Learning. I had the pleasure to be one of the project leads along with Dr. Robert Shanke, Associate Professor of Computer Information Systems. Rob is also the lead faculty that developed the interactive 3D model using Blender and Unity. Also on our team is Josh Eckenrode, instructional designer for virtual learning workforce development. Josh created the learning objects in Articulate Storyline and recorded plus edited the 360 videos in Adobe Premiere. Nick Landis is an education specialist in manufacturing and lead faculty in this area for workforce development. Nick served as the subject matter expert and developed the learning objects, plus he did the storyboarding for the AR objects with Rob. Cindy Shanke is the assistant director for online learning at Elizabethtown College and also an adjunct faculty at HAC, Central Pennsylvania's Community College. Cindy was our expert that created the artifacts for our learning objects in Adobe Photoshop. Our project started as a collaboration with our Pennsylvania TechLink schools and Commonwealth Charter Academy. After a discussion with our partners, we came to a decision that the area that we were going to focus on is precision machining. And how we came to this decision was our TechLink partners in particular had shared with us that many of their students just weren't interested in the precision machining program. And they shared that they felt that this was really due to a lack of understanding what is involved and what is the particular focus for this field. Along with them, we determined the objects that we were going to create with augmented reality. We selected an introductory piece of equipment. We felt that this would be feasible also as less complicated to learn. This learning content, though, can be used universally for learners in all precision machining programs. This will also allow for our TechLink partners to use what we've created as part of their own curriculum as well. Our next steps are to go out to the TechLink school open houses and engage with the students using the learning content. And we're hopeful that we'll maybe get some additional students to be part of either the program offered at their TechLink school or at HAC Central Pennsylvania's Community College. We are also very grateful that we were able to do this project thanks to the support of our HAC Foundation for this particular initiative.
What is precision machining? Precision machining is a process of removing excess materials from a piece of material called stock in order to create a finished piece that meets the exact specifications of the customer. When we started this project, we realized there was a need to increase awareness in precision machinery as a career. Introduce K to 12 students to the machine shop, but do it in a safe environment so they can practice and learn. Obviously, younger students, it is not really feasible to have them around dangerous equipment due to the risk of potential harm to them. Also, we realized there was a need to provide increased opportunities for the students to practice, reduce the cost of wasted materials and broken tooling commonly found when practicing for the first time ever on a real piece of equipment. With this, we also reduce the cost of maintaining large machine shop spaces as some schools cannot afford the extra space or the extra equipment, as some of this equipment is quite costly. It also reduced the time to learn how to properly operate the equipment because it gives students the ability to access the equipment from anywhere at any time with a simple laptop or phone. Once we realized the needs of the project, we decided to come up with the following goals. We wanted to give the students the ability to learn all of the components of a drill press without ever having entered the shop. This opens up a whole new world for some students who may not have the ability to get into a CTC class, or the financial ability to enroll into a college course. It provides a safe environment to learn. There's no fear of being hurt when you're working with a piece of virtual equipment. You can make mistakes over and over and over again without fear of costing any money to anybody. There's no fear of breaking a piece of equipment and potentially shutting the shop down for the rest of the students. It provides the ability for repetition of the labs and projects as needed. The student can do that same project over and over and over and over again without tying up that costly piece of equipment from other students and at the same time costing more materials. It reduces the time needed to teach the class with the skills, allowing for more time to do other hands on projects. If the students have the ability to work with the virtual drill press on their own time, they can learn the skills necessary, especially the ones relating to setting the proper speeds of the drill bits for the different operations and the different materials. It reduced the cost of wasted materials and tooling. As I said, they can keep making the mistakes until they get it right. So when we do actually get to the hands on portion, they get it right the first time. They have more confidence in it. And it reduces the amount of equipment and associated maintenance costs that you need in the shop. This is especially important for smaller schools that may not be able to afford multiple drill presses or be able to afford a lot of extra material for the students to be able to practice over and over on.
Now that we have a background of what precision machining is and some of the needs for these types of assets, we're going to take a look at where we are today and take a quick look at some of the tools and technologies that we use to get there. Now we're going to take a look at some of the hardware and software tools that were used in this project. We're going to skip over some of the more common ones, such as digital cameras and photo editing software, instead focus on things that we think are a little bit unique and important to augmented and virtual reality training. The first is Articulate Storyline, which was used for the computer-based training portion of the course. The next three are the camera and robot that are used to create our 360 videos, and Adobe Premiere Pro, which was used to edit that video. And then finally, we're going to take a look at the Unity engine and Blender, which were used to create the augmented reality application.
The tool that we used to create micro lessons for the drill press was Articulate Storyline. This program allowed us to create customized interactive experiences that takes us through the parts of the drill press and using the correct personal protective equipment to wear. In this example, we began by storyboarding the process with a subject matter expert and other instructional designers. We then moved the PowerPoint project into Storyline and developed out the different learning objects. Our objectives for the lesson were to prepare the individual to select the correct personal protective equipment and identify the parts of the drill press. This accompanies the AR exercise, which you'll see later on in this presentation. In this exercise, we asked the learner to select the objects that need to be removed or changed from Brandon. By clicking on the objects in the picture, the individual receives feedback on what needs to be removed and why that's needed. Also, audio feedback was included to help engage the learner. In this example, we're having the learner drag and drop the correct protective gear onto Brandon to what's needed to keep him safe. After you drag an item onto Brandon, the program allows feedback to be given to the learner in both text and video. We also have the same learning activity for the personal protective equipment for the gloves. Again, as you can see, a feedback is given to the appropriate response. And in this last example, we use a drag and drop simulation to help explore the parts and functions of the drill press. After the learner selects the appropriate spot for each labeled item, feedback is given to the learner in both video or text once the correct answer is chosen. We incorporated the use of 360 video in taking a tour of our manufacturing lab. We mounted a InstaPro 2 360 camera on a Double 2 telepresence robot. This is a remote-controlled robot that allowed us to record the room without anyone in it. This produced for us 360 video that we could edit in Adobe Premiere, and in the future we could use to add hotspots or other additional activities through the use of Adobe Captivate. This link will take you to a sample video of the tour that's hosted on YouTube.
So this will be the drill press that we're working with today. And you will see the belts are already off for our adjustment.
Hi, I'm Dr. Robert Chankey, and I'd like to talk to you a little bit about augmented reality in this project. Now, initially, we were looking at a virtual reality solution with a fully immersive experience for the student. However, we quickly decided against that because there were too many barriers to entry, specifically the cost of the equipment and the availability. We then looked at augmented reality and settled on that because we felt that most students today have access to some sort of a smart device, be it an iPhone, iPad, or an Android device. And if they didn't, they were fairly easy to acquire and cost significantly less than some of the leading virtual reality headsets out there. So to us, it was kind of a no-brainer that we should look at augmented reality for our purpose. As we did not need the fully immersive environment, we were specifically looking at the operation and use of a drill press. Now, to start this project, the first thing we did was have to find some 3D models. That was a little bit challenging, but luckily for us, the manufacturer provided some 3D CAD drawings for us that we were able to import into a software called Blender 3D. Within Blender, we were able to slice all the 3D objects to separate anything that we wanted to have interacting, such as the quill handle being pulled down, the drill bit turning, etc. Once we were happy with the model in Blender, we exported that as a package and imported it into our Unity engine. Within Unity, we were then able to add all the programming elements to make everything interact. Now, just if you're not familiar with Unity itself, Unity was originally created as a game development engine, so it has a lot of flexibility in terms of graphics, and it can handle a lot of complex programming with C Sharp. In our case, we're not doing a heavy graphic workload. We're working with a simple 3D model, and it overlays a real world camera behind that to create the augmented reality experience for the user. Now, in the next slide, I'm going to show you an example of the app that we've created. This is the first beta version of it. It's running on an iPhone. And what I've done is I have placed the drill press on my kitchen table. And you can see what the student would experience if they were to place that in their living room. They can walk around the object. They can look in and out by getting closer with the smartphone, and you can't see it on the video, but what I'm doing is I'm tapping the screen to interact with it by opening and closing the lid, turning it on and off, and moving the drill press up and down. And we feel that this augmented reality is a great supplement to the learning modules and videos that we've created because it gives the students a little more of a realistic experience to help prepare them for when they do come to the shop and are able to use a drill press for the first time. And this concludes our discovery session. We hope that you've learned something or that we were able to spark an idea that you may have for using virtual or augmented reality in your next project. We'd love to stay in touch, so if you're looking to partner with us or simply have questions about what we are doing, please reach out to us. On the following slides, you'll find our contact information and personal bios. And from all of us, thanks again and take care.
Thank you for your time today. We would love the opportunity to talk with you more about augmented reality and virtual reality. You'll see in the next few slides our contact information and also kind of more detailed bios about each of us that were involved in this particular project. So please reach out to us, email us. We'd love to talk with you more because we're equally interested in learning and growing in the field of augmented reality and virtual reality. So thank you, and please contact us. Have a great day.